some quick paper practice. We're going to demonstrate the odd numbered problems in each of these practice sets, and then you can try and complete both the odd ones from the video and the even ones with your own attempts. So let's just start with very old content review, but still valuable in terms of what each of these things means. I'm going to be doing this on a computer, but you will likely be doing this on paper, which makes it a little bit easier for you to write something. But the tools that I'm using, you can have open on your screen as well. For example, using something like Graspable Math. So I'll open up a fresh page here, math.new, and that way if I have any equation solving to do, I can do that over here. All right, so for the first one, it says state the coordinates of each point. I have points B, C, and D, and this is just reminding us when we read information written about a point, where does that mean that it is on the graph? So we're asking this question kind of in the reverse order that we're normally given it. So the first thing to understand is that every point is going to be written as a x comma y kind of combination, and the x value is that horizontal here where we go positive to the right and negative to the left. So for example, this point B is at 1, 2 for the right, so I'll copy and paste this, and B is going to be at 2 for the x value, positive 2. And for the y value, it's not at 1 or negative 1, it's right in the middle between those two numbers. So when it's on an axis like this, one of your numbers is going to be 0. Let's take this same item and make it, duplicate it or copy and paste it so we can write the other numbers. Let's do C next. C is, if I'm going in the x direction first, that's going to be at negative 2 for the x, and also negative 2 for the y. And let's do another one for D. And D is going to be at the x, the left and right direction, is going to be at negative 3. And for the y value, again, we're also negative, but this time it will be negative 1. We're only going down 1 from the axis. So that's just identifying points. What you need to write down is just a quick identifying value there. Now let's talk about the slope of a line. The slope is calculating like the difference in the vertical over the difference in the horizontal. So a lot of times I'll actually use this over here because it's a little bit better at equation writing. A lot of times we say that it's m equals and then a fraction, and for this fraction we'll say like the difference in y, so like the difference in y over the difference in x. And a difference is just a calculation, or not a calculation, it's just a subtraction, which is a calculation. So it's like the y2 minus y1 over x2 minus x1, that kind of thing. So that is what we're normally calculating to find slope. Oh, it doesn't like having two equal signs, so we'll do that. And what I can do then is try to calculate what's going on with this line here. Now with my pencil, and I have my mouse here that I'm clicking, but you guys can use your pencil to kind of trace these distances and see what's happening there. I notice that for the vertical distance, I'm going down or minus, let's see, from this blue point we have 2 and then 3, so down 5. And then for the horizontal distance, it's a plus 2. So that's just going to be a 2. And then the fraction that I need to figure out is going to be the vertical number over the horizontal number. So how do I write that? That's just negative 5 over 2. Don't have to do any additional calculation to it. It's just a basic kind of finding how much is the rise, a lot of people say. In this case, it's a fall, but how much is the vertical over the horizontal? Let's make sure we are copying to the clipboard, and then I'll paste it in here. So that's that slope, negative 5 over 2. It's negative because we're going downhill left to right, or that it's dropping as y changes over x. And you can also predict that number 4 is going to be a negative slope, but I'll let you calculate those differences. All right, now let's look at it a little bit kind of more challenging because we don't have a picture. I'm going to sketch a quick picture, just like a simple pair of axes here. So I would encourage you to also draw just a simple kind of cross. And I'm going to plot these points very roughly. So the first one is at 17, negative 1. So if I were to think of 17 down 1 is going to be about here. And that's the second point is at 6, which is closer to there, but way up for the y value at 19. So I have this difference. It's dropping from 19 down to negative 1. So let's write in just a couple of things here. We got, let's undo that. So I know that this top number is 6, 19. Up there. And the bottom one is 17, negative 1. So the vertical is going from a y value of 19 to a y value of negative 1. So how much is that vertical? Going up and down. That's going to be a value of 20. And you can do this with a formula calculation, but you don't have to. I'll show you how the formula calculation works as well. So it's going 20 up and down. And then let's see how much it is going horizontally. It starts at 6 and it goes up to 17. And if you're not sure how to calculate that, you can just do a subtraction, 17 minus 6. And that would be equal to 11. So the horizontal is 11. So what does that make my slope? It's going to be 19 minus negative 1. Highlight all of that, and I'll divide that by 11, or 17 minus 6. So this is how you would have seen it as an actual calculation. Then we start putting these numbers together, and it's just 20 over 11. So I'm going to copy and paste this whole calculation into there as well. Do you have to do the entire thing? Not necessarily. But it is kind of the way you would show all the calculation work. Could your picture count as a calculation work? Yes, you could have had the picture and then just labeled it with the 20 and the 11. All right, find the slope of each line. For number 7 here, when y is by itself, so I'm going to make a quick note. If solved for y is kind of your first step, and then the second idea after that is slope is the coefficient of x. What does that mean? It's the number multiplied by x. So when I look at this, y is solved because it's all by itself, and the coefficient is going to be this number here multiplied by x, which happens to be 7/3. So I'll just type the fraction 7/3. You would just write the fraction 7/3. And we're going to paste that in as our answer. Again, you're doing this on paper, so you can actually go probably faster than I can. Let's see if I can get that one more time. I don't think I pasted it quite correctly. Maybe it's not pasting, or it pasted somewhere else. But the slope then is going to be 7/3. 7/3. All right, let's look at the next page now at number 9. Notice this is where we probably got to use a lot more of this whiteboard solving equation kind of work. And again, you can do it in math.new and then copy it down with your pencil. Notice that I'm going to follow that same pattern. I want to solve for y and then look at the coefficient of x. I can't just say the slope is 1/3 because I haven't solved for y. So I'm going to type these things in. I got -1 equals -1/5 times y minus 1/3 times x. All right, so that's my equation, and I want to get y by itself. So I'm going to do a couple things. I'm going to drag this minus sign, which pulls the whole y term over there, and then I'm going to drag the -1 over to the other side. So now I have 1/5 y equals all this. How do I get rid of 1/5? Well, I can click on the equal sign to do something to both sides equally. And I'm going to multiply both sides times 5. 5 times 1/5 is just y. So that's great. And this 5 that's being multiplied here, I could have had it out front or in the back, either way. I'm going to multiply it into both of these numbers inside. This second number is going to become a +5 because 5 times 1 is 5. But the first one is 5 times 1/3, which is -5/3. So what is the slope then of this equation? The slope is going to be 5/3. So let's screenshot this piece. Make sure we're going to the clipboard. We'll capture that. And I'm over here and I will paste it. This is what you would be writing out for this equation, which looks like a lot. It is quite a bit of writing because you're trying to solve for y. And then what's the actual answer? The actual answer is -5/3, -5/3. And again, you can use a tool like math.new in order to do this, help with this equation solving. I think it's getting pasted somewhere and we're just not seeing it. And that's okay. There it is. It's all the way down there. All right. Now let's look at this next one. Very similar, very similar. We need to solve for y and then look at the coefficient of x. So I have 6y plus 18 equals 3x. Okay, well I need to solve for y, so I'm going to subtract 18 from both sides, and that gives me 6y equals 3x minus 18. Then I'm going to divide by 6 on both sides to get rid of that 6y. It just becomes 1y. And this is where a lot of students struggle. They're like, how do I divide? Do I divide it just to the x? Do I divide it just to the 18? Well, division works like multiplication when it's applied to an entire group, in that you have to distribute it. Well, to distribute this one, you drag the 6 up to one of them, and it's going to say, hey, you have to do that to both. And there we go. So the 18 over 6 is just -3, but I don't really care. What I do care about is that the slope is this number here next to x. It's 3/6. You could write 1/2. You could write 3/6. You could write 0.5. All of those would be correct. So I'm going to capture my work. But I only need to go this far because that gave me the coefficient, or that number multiplied by x. Again, it seems like a lot of work, and it's mostly because you're solving an equation for y. So I want you to try and copy this work in here. You might have to do it in a couple of rows to show all the steps. And then we can capture that coefficient as 3 over 6. That is our actual slope. There we go. Capture, paste it in here, but it probably went somewhere that I didn't see. There it is. So that's the slope. Find the slope of a line that is perpendicular. Okay, for perpendicular, I want you to write these things down on your paper. Perpendicular slope what does that mean? It means a couple of things. Oops, there we go. Let's try and drag this out like that. There we go. The first thing it means is it's a reciprocal. Another way to say that is flip it. Flip the fraction. And the second thing to say is it's the opposite sign. The opposite sign means that something's going to be positive and the other one's going to be negative. So when I look at this slope, it says -6 over 5. So what is the flipped and other sign? That's going to be 5 over 6 and positive. So that's the fraction that I want to put in there. So that's a fraction that you're going to write in here, 5 over 6. For the next one, very similar. We take the fraction, we flip it, and we give the opposite sign. So this one's negative. That means ours is going to be positive, and it's not 3/5, but instead it's 5/3. Paste that in here. Looks like it pasted over there. So it's 5/3. So we got 5, 6, 5/3. Now let's look at 17 and 19. If you look at these, you'll notice that we don't know what the slope is because y is not by itself. So I got to change that equation so that y is by itself. It says 3y plus 6 equals 3x. So let's change this equation so that y is by itself. The first thing I would do is subtract 6 from both sides, and that's going to give me 3y is equal to 3x minus 6. The next thing I'm going to do to make this just 1y and not 3y is I'm going to divide by 3, and that gives me y equals 3x minus 6 all divided by 3. So I got to distribute that dividing to both terms. And then I get 3 over 3x. You could also rewrite that even more simply as just 1. So here's all my work in solving the equation. This is what you need to write in there. And then the slope that's perpendicular. So the fraction for the original slope is 3 over 3. The perpendicular slope is going to be that flipped and the opposite sign. So when you take 3 over 3 and you flip it, it's still 3 over 3, but now it's negative. What are other ways you could do that? You could say negative 3 over 3. You could also just say negative 1. So either one of those would be a correct answer. There's actually infinite correct answers as long as they're equal to these numbers. So we pasted it. Here is the actual answer. Make it a little bit smaller so it fits in here. So that's our actual answer for the slope. Okay, and let's refresh this because we got another one to solve and figure out the perpendicular slope. Now we have 12 plus 3y minus 4x equals 0. Okay, so I have 12 plus 3y minus 4x equals 0. And if I'm looking at this, I want to get y by itself. I'm going to first add 4x to both sides, and that will give me a plus 4x on this side, but only a 12 plus 3y on the other side. Then I'm going to do a subtract 12, and that will make this side just 3y. And on the other side, I have 4x plus 12. Now the last thing, to get 3y to become just y, I'm going to divide by 3. And that gives me y on that side, but now I got to distribute this division. And my coefficient is 4/3. So again, I got a lot of stuff going on here. I'm going to show you how you could write this kind of in 2 halves. So we start out with like the first half. Capture that, paste it in. But these few steps would fit a little more neatly in here. And then the remaining steps will be the last ones down here. Capture that, paste it in. Cool. And what is the perpendicular slope? So the slope is 4/3. The perpendicular slope, you would flip it and change the sign. So 4/3 becomes 3/4, and we're going to change the sign to negative. So that is my perpendicular slope. It's negative 3/4. That's my answer there. Okay, so these last two are probably the hardest ones, and if you don't get to these, it's not the end of the world, but these are the ones that require kind of like the most work going on, because you're doing a couple of things. You are writing an equation, and you're using something that it's perpendicular to. You're using some information about a slope. Now this first one, it says perpendicular to x equals 0. So that one's almost too kind of unique, but that's okay. So I'm going to do a couple of things. First, I'm going to open up Desmos calculator, and I'm going to show you what x equals 0 looks like. It's just a vertical line. So what would be a horizontal line? Anything that's equal to y. So y equals 4. That would be perpendicular. But it goes through the point 0, 4. And what we want it to go through is the point -5, 1. So we want it to go through this point, but be perpendicular to the red line. So instead of y equals 4, I'm going to change it to y equals 1. So this is just using a graphing calculator, and it's more than fine to do something like that with Desmos. This won't be as easy with our next one because we have some equation rewriting to do. So I'm going to capture that, and then I'm going to paste it in here just as a little bit of work. And we'll write the equation out. There we go. Try to make that picture a little bit smaller just to show a little bit of my work. And the equation then is y equals 1. Y equals 1. All right, this last one, this is our kind of big finish line with a lot going on in it. So first of all, we're going to write out the original kind of point slope form of an equation that it talks about. point slope form is y minus y1 equals the slope m times x minus x1. Okay, now the point that we're given is that it's negative 2 comma 5. So negative 2 comma 5 equals x comma y. I don't think I can write that in here, but my x1, y1 is negative 2, 5. Let's see if it lets me write it. Oh, it does. Awesome. So that's what I'm going to plug in for my x1 and my y1. The slope, though, has to fit this criteria. It says that it's perpendicular to this line. Well, if it's perpendicular, then I know the slope. I'm going to do some things like I did in the previous problems. I'm going to flip the fraction and change that sign. So negative 1/5 becomes 5 over 1 and positive. All right, so that is my slope. I'll put m equals. We often use the word m for slope. Now that I have all these pieces, I just need to rewrite this equation using these numbers. So the equation then is going to be y minus the y value, which is 5, equals the slope, 5 over 1. You could just write the number 5 and it would be the same, times x minus the x value, which is negative 2. Awesome. So we have all this work here that kind of goes into capturing this problem. I am going to do a little bit of moves here just for something that you're going to be more familiar with on the work that we have in our skill quizzes. On our skill quizzes, we take this value from y and we move it to the other side for its opposite. So it's just y by itself, kind of like we had with other equations. Also, whenever you have two signs like this, it's like they're multiplying, and if I put them together, a negative times a negative is really a positive. So it's not actually multiplying, but it does work like that. So if you have a minus plus, that's going to be a minus. Plus minus, that's the same as a minus. Minus minus is the same as a plus. All right, so this is all my work. I'm going to capture all of it. This is the work that you would want to write down. Capture that, and then we'll paste this in here. All right. So in class, we will at this point have done most likely a pre-quiz with quizzes, and then you will go through and do these notes, and then you'll come back and do a second round with the quiz, and then toward the end, we're also going to do a little bit of exploration with a Desmos lesson. And that's it. Thank you.